Hello, embedded system lovers. Have you ever wondered how everything from your smartphone to your Arduino project runs on something you cannot even see? Electricity. But where did it all begin? Let's find out. Thousands of years ago, the ancient Greeks noticed that rubbing amber could attract feathers. But it wasn't until the 18th century that electricity really came to light, literally. In 1800, Alessandro Volta created the first chemical battery. A few decades later, Michael Faraday discovered how magnets could produce electric current, a breakthrough that powers modern life today. From the flick of a switch to the logic of a microcontroller, electricity is the invisible engine behind everything we build in embedded systems. In this series, we will uncover how it works from atoms to Arduino. Join me, let's dive. Electricity is not a buzzword. It's the movement of electric charges, mostly electrons, through a material. This movement, called electric current, is what powers everything from motors to microchips. This is what electricity is about. Voltage is measured in volts. The higher the voltage, the more energy each charge carries. Current is measured in amps. It tells how many charges are moving past a point every second. But what pushes those charges? That's where voltage comes in. It's the force or pressure that drives current through a circuit. You can see a water analogy, a tank pushing water down a pipe. The same way the battery is pushing the current. So voltage is the push and current is the flow. Together, they make electricity work. And next, we will see how resistance controls. You now know that voltage pushes current through a circuit, but not all materials let current flow freely. That's where resistance comes in. Resistance is measured in ohms, and it's what limits how much current flows through a circuit. Check out my every circuit simulation. I use a mobile phone to simulate this using every circuit app. You can get it on Play Store. Now, when I keep increasing the resistance, the LED dims. Alright, but when I reduce the resistance, you can see it becomes brighter. Law, from this Ohm's law triangle ties all this together. V, which is voltage, equal to I, current, times R, resistance. Alright, so if you need to control current in a circuit, just change the resistance or the voltage. In this circuit, you can see how I'm changing the resistance, and you can see the effect on the LED, how it's dimming and how it's increasing. Another important concept to learn is the series and the parallel circuit. Now let's check out the series circuit. Now let's say you connect two LEDs in row, as you can see on screen. That's a series circuit. One part, one current, and if one of the LED gets burnt, everything stops working, as you can see on screen. You can see both LEDs are working. Why? Because the both of them are well connected and none of them was bad. That was why the two of them are working. But when you disconnect one or one gets faulty, the both stops working. That's series connection. Alright, now let's see parallel connection. In the parallel circuit, each of the LED has its own path to the power source, which is the 9-volt battery. So when one of the LED goes out, let's say it's faulty or it gets burnt, the other keeps shining, it keeps working, nothing gets bad, unlike the series circuit connection where one of the LED gets bad, the both LEDs stops working. But in the parallel connection, when one of the LEDs get bad, the other one keeps working. Why? Because they have their own path to the power source. So you can see the connection that both ends are connected to the power. So here is the trick. In series, voltage splits. In parallel, current splits. Understanding this will help you design smarter. Now let's clear up a common confusion. What's the difference between electricity and electronics? Or we can as well say, what's the difference between electrical and electronics? Electricity or electrical deals with the generation, the flow, and transmission of electrical energy. We can also think of it like water flowing through pipe, just as you can see on my screen. So water flowing through pipe to represent current. Alright, is what we consider as electricity. After stating the meaning of electrical or electricity, electronics, on the other hand, focuses on using that electrical energy to control, process, or communicate information. Now, switching on a light bulb with a switch, that's electricity. But when it comes to electronics, programming a microcontroller to blink an LED like this on screen, that's electronics. So we can comfortably say electricity means power flow. Electronics means controlled behavior. Electronics makes use of semiconductors, transistors, and integrated circuits to manipulate electricity in intelligent ways. This is the foundation of embedded systems. Electricity begins at an atomic level where electrons move around the nucleus in regions called orbitals. When electrons move from one atom to another through a conductor, that's what we call an electric current. And that's the heartbeat of every electronic device we have in our modern world today.